Hey guys, so today we are going to be doing estimating finite sums. And basically what this is we are just trying to find or estimate an area under a curve, dealing with time and velocity. Um, so yeah. Okay, and then to start, we're basically going to be doing a graph that has a constant velocity just to show the relationship and show how to find that curve or how to find that area under the curve. So we're going to label these axes. Um, this is going to be time, and this is going to be velocity, meters per second. And we're going to have 5 here. And then we're going to do these by tens. And if we draw our line like this, and we're wanting to find, so basically we know the relationship is d equals vt, where we're trying to find d, which is distance traveled, which will be this area under the line here. So we know we're trying to find d, so that equals, so whatever we want to find. So if this is at 30, and let's say we want to go to 4, okay, we'll draw an imaginary line. This is the area that we're trying to find here. So in this case, the v represents the velocity. So v is 30 meters per second times, and the t here is 4 for time. 4 seconds. Okay. So then d equals 120 meters because these seconds cancel out. And so then you're just left with 120 meters, which equals d, which represents the area under the line here. So now that we looked at the graph in relation with constant velocity and how to find that area under the curve, just simple multiplication, we're looking how it applies to a graph that shows constant acceleration. So it would look something like this, a nice straight line. Okay. So in this case, we're trying to find the area under the line to the x-axis. So we want the area, or still d. And because of this shape, we're going to be looking for the area of the triangle. So let's say we're cutting it off around here. Then we're looking for this whole area here, and to find a circle you need that, or to find the area of a triangle you need that equation. And so now let's fill it in. 1/2. 4 is still time here. 4 seconds times 40 meters per second. Multiply all this out. A is equal to 80 meters, with these seconds canceling out. Now we know that constant velocity and constant acceleration graphs and finding the area below them is very common and very easy. But then we get to the question of can we still apply this same knowledge and ideas to something that has something like a variable acceleration. So and what something like that would look like would be more of a curve like this, right? And the question is, how do we find this area under the curve, right, when it's a little bit more tricky and not as straightforward? Okay, so since finding this exact value under the curve would be very hard, we're going to use what this chapter is called an estimate finite values. So what we're going to do is we're going to use these chopped up sections and we are going to make rectangles out of them, and we're going to try to get as close as we can to the true number or the true area as we can, um, by using these rectangles. So we're going to use these four slices in a thing called LRAM, which stands for left hand rectangular approximation method. And there's a couple other variations of this method, but this is the left hand method. And basically what you're going to do is on the left hand of each section, that's going to be the top of the box. And then you go over like this. That's the first rectangle. So you go where the left hand of that section meets the curve. So see how it goes a little bit over? That's okay because we're just estimating. So that's 2. That's where that one meets. And that's where that one meets. So you can see that it's not super precise, but some are above and some are below. So we're going to get pretty close using this method. So to actually use this method to estimate the area, what you want to do is you want to break it into different sections like this. And notice how we didn't do an f of 4, and that's because we're going from the left. So we have the 0, 1, 2, and 3. If we were to do 4, it wouldn't make sense because that's not how many sections we have. So now, to find the areas of each of these, we got to look at the height. So for these first two, it looks like they're about 40. So we're going to write 40 for these first two. For f of 2, right here, it looks like it's about 30. And then for f of 3, it looks like it's around 25. Since this is a whiteboard drawing, it's not super accurate, but it's just to get the idea. So then, to find the area, you obviously multiply the height by the width, and so the width is going to be the size of each of these sections here, and in this case it's just 1, but sometimes they'll be a little bit messy and can be fractions, but we'll talk about that a little bit later. So with this first one, f of 0, we just multiply by 1. Same with this one, they're all the same size. And basically you're just gonna, these are all just like this. So then you're gonna add them together. Okay, so yeah, we're just going to add them all together. So it's just 80, 110, 135. So this area is going to be 135. But now for units, remember from the last problems with constant velocity and acceleration, these are just meters per second and seconds. Seconds cancel out, so this is just 135 meters. So there's actually two other ways of estimating with this rectangular approximation method. So let's see. Basically, we went from the left hand last time, but there's actually still the right hand and the middle, which are very similar. However, they are slightly different. So again, we have our 4 sections here. And basically what we're going to want to do is, so 1, 2, 3, 4. So now we're going to be going from the right hand. So it's going to be f of 4, f of 3, f of 2, and f of 1. Notice how there's no 0 this time because we're not going from the left. That's all right. So if we go from the right, where we have this meet up with the curve, and then it goes over, and it comes down. This one meets with the curve, goes over, comes down. This one meets with the curve, goes over, goes down. And this one's way up here. Okay. So those are some rough sketches, but at least we get the idea of this right-hand method, which is very similar. So let's say that these are 10s right here, 20, 30, 40. So if we start with f of 4, let's say that's about 35. Okay, then 3 looks like it's about 20. F of 2 is also about 20, maybe a little bit less. Let's say 18. And then finally, f of 1 looks like it's about 35 as well. Now, all of these sections are 1, just like the left-hand method. And it's going to equal to something in meters. Yep, okay, so this is going to equal 108 meters because, again, you had the meters squared for this one and the time to cancel out just meters. Okay, so on the same graph, using the same sections, the last thing is called middle rectangular approximation method. So basically the middle of each of these sections is what we're going to try to line up with the curve. So it'll look something like this. This is where it's meeting up, right? So it'll come over like this, and then down like that. And then for this section, the middle is about there. So that's going to be the top of that rectangle. The middle is about there. So that's going to be the top of that rectangle. And then for this one, the middle is about there. So that's going to be that rectangle. And you can see that parts of each of these are going to be above and below, so it's going to be decently accurate here for this estimation. And I'm not going to draw it all out, but it's the same type of solving with this MRAM, where you find the height and width of each of these rectangles for these blue, and you just add them all up to find the total distance traveled. Okay, so now to finish off, I'm just going to leave you guys with this practice problem here. So basically what we're going to try to do is we're going to try to find the LRAM and the RRAM of this graph. So you can see I already put all these down for the left, going from left to right. Notice how there's no 3, but from this side, we're going to go f of 3, f of 2.5, f of 2, f of 1.5, f of 1, and then f of 0.5 here. And sorry, I forgot to add the f of 0 on the left side. But so basically, graph this somewhere on your graphic calculator or on a piece of paper, and just create these boxes and then try to solve these, and then come back, pause the video. So now we're back. Hopefully you did the same as I did and you made all the rectangles. Maybe you made 2 graphs and did them separately, but I just did blue for left and red for right. And then these values right here are the height times the width, and then I just wrote them all out in a line. And remember that each section is 1/2. So as you can see with all the f values. So if you didn't already add all of the numbers up, add them up now so we can see what we got. So after adding up all the numbers, this is what I got. I got 62 meters for the LRAM and 54 meters for the RRAM. Now you can see that they're a little bit different, however they are pretty close, and the whole point is just estimation, getting as close as you can. So I hope that helped, and that's going to be it for today. Thanks guys.